Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop a medical bot using Llama 2 model. Okay, Llama 2 is been released by Meta AI last week, and after that, the entire open source community have worked on quantization and different ops to make it available to run it on a compute limited devices like a CPU machine. Okay, and that's what I'm gonna show you in this video, that how you can basically take a quantized model from Hugging Face and you can build your own chatbot, okay, on top of your data and knowledge bases that you have. That's what I'm gonna show you in this video. So let me first show you that what I have built. And you can see on my screen we have something called hi, welcome to medical bot, what is your query. Very simple interface, and this is what I have built, and this is what we are going to build in this video. Okay, we are going to develop this from scratch. Okay, I'll show you that how you can build your own bot using Llama 2 or any other open source large language model. Okay, so if I ask a question and it should generate some response for me. Okay, this is the document that I have taken. You can see the document, the knowledge base, the data that we have, the Gill Encyclopedia of Medicine, which has around 600 plus pages. Okay, 600 plus pages, like an encyclopedia of medicines. Okay, that's what I have taken, and I have created embeddings out of it with the help of an open source embedding model, and then I feed it to a large language model with the help of some frameworks like LangChain and Chainlit, to retrieve the response from it, or retrieve the information from it, right? So if I ask a question here, okay, what is Llama or something? Okay, let's ask this. You can see Llama is a general term used to describe a variety of conditions that cause an itchy, inflamed skin rash. Atopic dermatitis is a form of eczema, that is non-contagious disorder, something like that. Okay, we're also getting the sources, the document, the metadata of it. So I have asked the question, and you can see the step over here. We have all the steps: retrieval, QA, stuff, documents, everything. I'll explain this when we're going to develop less of talking and more of coding, guys, in this video. Okay, that's what we're gonna do in this video. So let me first ask some other questions as well. What question we can ask? What is an anti-diabetic or something like that, diabetic drug? If I ask this question, okay, what is an anti-diabetic drug? And you can see what it does. It kind of starts the chain using retrieval QA. So retrieval question answering chain from LangChain that we have used. And the good thing about this framework that we are using, the Chainlit, which is again sounds very similar to Streamlit, right? To build Python apps, but Chainlit is more for building chatbots on top of a language model or a large language model, because Chainlit provides a lot of features that I will explain when we are writing the code there. Now it will retrieve the information for you. If you click on this, it says using retrieval QA, using stuff documents chain, using LLM chain, and I can also see LLM chain is running. And once it will take little time, because the main agenda of this video is to run Llama 2, build a project on top of Llama 2 and run it on a CPU machine, because not everybody owns a GPU or VRAM, right? Not everybody has that, right? So that's the reason that we are doing it, and it will take little time when you are on CPU machine to retrieve the answer for you. But this is what we're gonna build. Okay, so you can see it's on Chainlit. So let me first show you what Chainlit is. Now if you see the Chainlit over here, it says Chainlit lets you create chat GPT like UIs. So it helps you create conversational interfaces, okay, with ease. And the GitHub repository will be given to you, and they have a lot of samples app that you can take and develop on top of it. They have integration with LangChain, Pinecones, etc. Okay, they have their docs here on docs.chainlit.io, and you can find out everything that you need. And that's what I have also taken some references, and I have built this. Okay, now let me just go back to terminal here and show you. You can see it says batches 100%. It's loading, 3 changes detected. Now if I come over here, you can see anti-diabetic drugs are medicines that help control blood sugar levels in people with diabetes mellitus. Fantastic. This is fantastic. You are running Llama 2 quantized model on a CPU machine, and we are not only running it, we have built a custom GPT kind of a thing where you have your own private data. okay, your confidential data, and for example you want to run this on a CPU machine or inside your own infrastructure or network, you can do that. We are not using any kind of APIs here, guys. And you can see the quality of bot, and of course you can beautify it later. I'll also give you some links that how you can, you know, clear this or clean these sources and all. There are a lot of features on Chainlit, but this is what we are going to develop. So and this is going to be an exciting video, guys. Now I hope you will learn a lot from this video. This video is going to be very lengthy. As I said, less of talking, more of coding. So I hope you will spend some time with me on this video. If you want to do it alone, if you want to just rely on the code will be available on the GitHub repository. You can find it in the description. Please take the code from there if you are not interested, you know, watching the video. But if you watch this video, you will learn a lot of nuances about this entire workflow. That's what I'm going to cover it. Each line I'm going to explain. Okay. So let's now build this application, guys, this chatbot that we have built that I'm currently showing you. Let's start building this. Let's start writing some code, guys. So now let's build the bot, guys. So you can see I am in this folder. I have a folder on desktop that's called Llama 2 demo. So what I'm going to do here, I'm going to open this in terminal. I use Ubuntu, but you can also use any other operating system you want to use. I'm on Linux right now, and you can see I am in this directory. I'm going to open this in code, VS Code. I'm just going to hit code dot. Same is applicable on Windows as well if you are using PowerShell terminal or CMD as well. Now you can see these are the requirements, the minimal requirements to run this bot, to build this bot and run this bot. You can ignore bits and bytes. It's not required right now to run this on CPU. Okay, but these are the minimal requirement that you need, you know, to run the app. Now few things. We need a model to we have to download a model. We need a model so that we can use that, and I'll show you that which model you have to download. I have this model called Llama 27B Chat GGML Q80 bin. So we need to download this model. You can see this is the model that we have to download. It's by the block. Now if you click on the block, it's by Tom Jobbins. Okay, thank you so much. You know, we have to give credit to Tom Jobbins or the block for all the great things that he does with LLM quantization, fine tuning, and ops on the Hugging Face. And he has been very, very instrumental to empower the open source community. Okay, so huge credit to him. Thank you so much, Tom Jobbins, if you're watching this video by any chance. And this is the model that we are going to use. This particular model, you can see that Llama 27B Chat GGML v3 Q8. You can see here on files and version, and you can see the quantized bins, and you can see this is the model that you have to download. LFS is large files. You can click on this and you can download it from here. Still download it. Right? It will take a little time for you, and that's the model that I have. This is the model you can see in my folder, which is around 7.2 GB. I assume that you need minimum of 13 GB of RAM to run this. So I have 16 GB of RAM in my system, and I hope that it will be decent enough to run this. Maybe you can try on 8 GB as well, but that will probably crash your system after one question. Okay, so you have to offload the weight over there. Then I also have a requirements txt I have shown you, and I have a data here. Inside this data I have this file, the file I was showing you earlier, and I'm going to use this data. You can use any other data. You have one file, you can have 1000 files depending on the compute power. Okay, so it depends how many data files that you have and what you want to do with this entire workflow. So I'm going to rely on this one file, which is huge again, right? 600 plus files. Now let me show you what we're going to do here, guys. How does this work? Okay, so we need a large language model here. You know, we are living in the era of generative AI. We have LLMs. We have LLMs here, right? Now, how does this work? What are the things that we need, guys, to build this? Let me just do one thing. Let me show you step by step. Okay, I'm gonna build a medbot using Llama 2. So for that, we need this Llama 2 model. But we cannot get it from Meta AI to run the model on CPU machine, because that will probably not work. So we need a quantized model. Now this quantization is again 4, 8 bits, different bits of quantization. We need a quantized model, and the thing that we need is we are going to take this model from something called the block on Hugging Face. I'm writing HF for that, and the link will be given in the description, and also I have just shown you that how you can download it. So the block on HF. Now once you have downloaded this model, you have to load a model. So how do we load a model from Hugging Face? So we take help of transformers, but we cannot load this model from transformers if you want to run it on a CPU machine. We have to use something called C transformers, which is a Python binding in C++. Okay, I'll show you what C transformers is, and you can also see that C transformers in my thumbnail. So let me just go on C transformers, something like this, C transformers GitHub, and you can see Marilla C transformers, Python bindings for the transformer model implemented in C++ using GGML library. Okay, this is interesting. So we're taking the model from here, and then we use C transformers, Python bindings, and the model that we are talking about, this model on quantized model, this model will be should support GGML. So you also have GPTQ models. Okay, if you are familiar with this terminologies, GGML, GPTQ, that helps you run this model on commodity hardware. Okay, that's the beauty of it. Okay, GGML of C transformers, and then we'll use sentence transformers. Such an underrated embedding model, guys. Sentence transformers. We are going to use all mini LM, mini language model V6. We're going to use this model to create the embeddings, and then we need a vector store, because you have created embeddings now. Then you have to store those embeddings in a lower dimensional space, and that's why you need some kind of vector database or vector stores. And that's why we are going to rely on a vector store. Now you can use different things here. Okay, I'm writing something, but you cannot see it because screen is not casted. Let me, yeah, now you can see. So vector stores, and these vector stores are of different types, or different vector stores are available there. So the most famous nowadays is ChromaDB, which I really don't like. So you have ChromaDB, and then you have Faiss. It's by Facebook. We are going to write CPU here because it's also given in GPU format. Then you have Qdrant, and then you also have, I'm not going to talk about any open closed source things here. You have Pinecone, but it's again closed source. I'm not going to rely on that. I am an advocate of open source AI, guys. So these are on the open source. We'll talk. Qdrant is available through Docker images as well, which is very interesting. Now, so we need a model, Llama 2 model, because we are relying on Llama 2 because it is performing very well on leaderboards. Okay, and some new also. And then we need C transformers, sentence transformer, vector store. So let me create a high level diagram for you, the architecture, and then we'll move on to the coding part. You will have your document, and let me write this docs, or basically we can also write it data, right? You have your data. Now you need to pre-process this. So let me write this pre-process, and this pre-process happens through LangChain. It does all the heavy lifting for you. So LangChain loaders, splitters. So you have LangChain loaders, splitters, recursive character text splitter, unstructured loader, PyPDF loader, directory loader, thousands of other loaders that you have probably in LangChain. Thanks to LangChain. You know, I'm a huge LangChain fan. Okay, but there are issues with LangChain in productions that we will cover in some other videos. So you have docs data. Now LangChain for all the pre-processing. Now once you have loaded this text, you have splitted this text, your text is ready, the pre-processed text. We will pass this to an embedding model. So let me write that. Embedding model, and in our case, our embedding model is nothing but sentence transformer. We are going to use one of the model from sentence transformers. So you can see sentence transformers for embedding. Now once you have these embeddings, you have to store that somewhere, right? We have to store that in a lower dimensional space, as I said earlier, and then that's where we use a vector db or store. And in our case, we are relying on Faiss in this video. So Faiss CPU. You can also use Chroma DB if you want. I'm not getting good results with Chroma nowadays, so I'm gonna write, okay, excuse me, Faiss CPU. Now once you have Faiss CPU, once you have the vectors stored into it, now the user will do a prompt. User will do a prompt, on the screen. Now suppose this is your screen, and the prompt will again go to this Faiss CPU again with the help of LangChain here, Faiss CPU, and then it gives to an LLM and it returns you the response. Yes, this is a high level architecture, guys. I'm not covering chunks and text chunks and a lot of other things, but this is a very high level architecture, very high level architecture that I've shown you. Okay, so few things to cover here. Now what does happens in vector stores? What really happens inside vector store? Inbuilt similarity algorithms. Cosine similarity, you would heard about it, guys, right? You have heard about cosine similarity, Jaccard, Levenstein, lot of other algorithms. Inbuilt, they are faster. So no latency issue as well. So I'm going to write no latency issue. And metadata, etc. Right? So these are the features of vector stores. Now this is a high level architecture, for this bot. I hope you understood what are the things that we need. We need a model. So we are going to rely on a quantized model, Llama 2, GGML model, and then we have a C transformers. We are not going to load the model from transformers. We are going to load it from C transformers, and then we need sentence transformers for embeddings or vector stores, and then we are going to pass this to model again with the help of LangChain. Right, so let me just go now and start writing the code, because I'm really excited to write the code for this. So let me come over here on VS Code, and I'm going to create a file called ingest.py. So ingest.py, and the first thing that we need is from LangChain. It's all LangChain thingy now. So from LangChain let's have something like text splitter. So text splitter import recursive text splitter. No, it's recursive character text splitter. So let me write recursive character text splitter. So this is okay. So from LangChain dot text splitter, this is okay. Now next thing is from LangChain dot we need a document. So from document loaders. So from LangChain dot document loaders, let's import. We are going to rely on PDF, guys, but you can also use any other format. If you have unstructured data like PPT and text file, please use unstructured loader. So from PyPDF loader, and then I'm going to use directory loader here. So let's do that in this case, directory loader. We are good with our load here. So from LangChain, and the next thing that we need is from LangChain dot, we need the embedding model. So we have to load it from Hugging Face embeddings. You can directly load sentence transformer as well. Sometimes it might behave, it might really give you some trouble, the Hugging Face embedding, due to version conflict. But you can, if you are getting any error with Hugging Face embeddings, you can replace this with sentence transformers. It's completely fine. So from LangChain, embeddings are done. We need a vector store. So let's do that. So vector stores, import Faiss, Facebook AI search or something. I forgot the full form of it, guys. Okay, it's something with similarity search or something. That's it. So we have our import for this ingest.py. We have document loaders, text splitter, embeddings, and vector stores. Now let's define a data path. So data underscore path, and here I'm going to pass my, you can see the data that I have in this folder. So I'm just going to do data within that data, and I also need to create something, and I'm saying, okay, whatever embedding you create, you store this in this folder. Okay, so let's define a path for this folder. So let's call it vector stores and db underscore Faiss. db underscore fast. So whatever you do now, you do inside this, guys. Okay, all my embeddings should get stored inside this root, this path. Now let's write a function. So I'm just going to write create vector database. So create vector database, and now let's write define create vector db. So let's do that. And inside this, the first thing that we have to do, guys, we have to have a loader here. So let's do a loader. I'm just going to do a directory loader in this case, directory loader. And then in the directory loader, what I'm going to do here, let's have a data path which is right, and then I need excuse me, we can write in the one line because it's not that big. So globe, which is looking at the extension of it. Okay, and let's have an struct.pdf. So we only accepting the PDF right now, and then we have a loader underscore class, and I want this library to be used, to get the PDF data, which is PyPDF loader, and that's why we have imported that. As you can see, PyPDF loader. Now loader is okay. Now the next thing that we're gonna do here is we need a documents variable. So documents and loader.load. So let's load the file, documents loader.load, and then we have to split this to text splitter, correct, thanks to tab 9. And I'm gonna use recursive character text splitter. So let's do that, guys. So not recursion, sorry, recursive character text splitter. Inside this, let's pass a chunk size and chunk overlap. Let's keep a 500 chunk size, for text splitter there. And then we need chunk overlap. Let's keep a smaller chunk overlap for this demo video, guys. You can extend this further, this app. Let me know what you built with this, after the video. So chunk size and chunk overlap, we are good with the text splitter. Now what I'm going to do here is I'm going to call it text and text splitter dot, yes, split documents. We need to split documents, and inside this split documents, you're going to pass the documents, and then let's use embeddings now. Now we're going to pass this text to create the embeddings. Okay, so I'm going to use Hugging Face embeddings, and inside this I'm going to pass my model name. So my model name is nothing, but it's going to be sentence transformers slash all mini lm L6 and the version 2. So this is okay. Now I'm gonna do an alt G here. I'm gonna use model quarks. I want to put a CPU over there, so I'm just gonna use a device value. So device would be CPU. If you have a GPU machine, probably that will be wonderful for you. I do have a GPU in the same machine, but I want to run this on CPU. That's why I'm creating the video for you guys. Not everybody has a CPU, as I said, a GPU, sorry. And then have a DB variable, and I'm going to use Faiss.from, and I'm going to use documents here, guys. And in this documents, I'm just going to pass text and the embeddings. That's it. So what we are doing in this function, guys, we have this text which contains all our splitted text, and this embeddings model that I'm going to use from sentence transform. I'm passing this to Faiss. I'm saying, okay, here are my text, and you use this embedding model to create all the vectors and store it in a database or a store, not a DB in this case, but a store DB, and then do save local. So I'm saving it locally. In Chroma I would have basically we've been doing persist, right? So in here we are going to do db Faiss path. That's where we are saving this, right? You can see db Faiss path. That's it. Now what I'm going to do here, I'm going to use if name main create vector db. That's it. So we are good with our file, guys, our ingest.py. Okay, now we will run this, and automatically it will create a folder over. It will take a little time, but it will create a folder. And once we have this ingest.py ready, we'll start writing code for our model.py or the app.py or the bot.py, whatever you call it. Let's run this, guys. So in terminal, what we are going to do is we are going to do Python and you can see I have to activate that environment. So let's activate my LangChain environment. I have an environment where I've installed all the required dependencies, and here I'm just going to do python ingest.py. Now when I do python ingest.py, it should probably run the file and should create the embeddings for me, and it should automatically create a folder, and it will save all the embeddings, the index, the metadata in that through, I think it's a pickle, the pickle file that it will get saved with an index that you can see it over here in the Faiss folder that we have, vector store db Faiss. That's what we are going to do. Okay, now let's also create a model file, because that will take little time. Meanwhile, I'll create a model.py file where I will run write all my code for the bot, and then we'll run this file model.py through Chainlit. Okay, so let's come here. It will take little time because it has around 637 pages of PDF, and it's a huge file, and that's why it's taking little time. It will take probably up to 3 to 4 minutes to do that, but let it complete. Now let's write the code for our model, guys. So the first thing is the import. So again, LangChain, thank you LangChain for all the heavy lifting that you do. So from LangChain import, we're going to import a prompt template. We're going to write a custom prompt for this. So prompt template. So from LangChain import prompt template, from LangChain LangChain.embeddings import. So from LangChain.hugging face embeddings, from LangChain dot vector stores again import Faiss, the same thingy that we did. Now here a couple of more things will be added from LangChain dot LLMs. It sounds really good. LLMs, large language models. More than 15,000 large language models are available on Hugging Face, guys. Recently I saw a chart from one of the Stanford researcher. Okay, it was very fascinating. So from LangChain.LLMs import C transformers. Here it comes, guys. C transformers. And people still rate I don't know, Python higher than other languages. C++, such a fundamental programming languages. Okay. Now from LangChain.LLMs import C transformers. Now what I'm going to do here, from LangChain dot chains, we need a chain here, guys. So there are different type of chain: conversational, retrieval, and I'm going to use a retrieval chain. But if you really want to focus more on chat history, you can also use a conversational retrieval chain as well. So I'm going to use import retrieval QA. That's it. Excuse me, I don't know why I can see a Keras thing here. Keras 3.0 has been released as well. So retrieval QA, and then we need to import Chainlit as CL. They have copied that lit from Streamlit, it seems. Okay, but this is very interesting. I'm spending a little time nowadays on Chainlit as well. Now we are done with our import. Let's write the same db Faiss path because we need that. So I'm going to write here again vector stores, and vector stores, it will be not db, it will be db. And now, okay, you can see we have a folder in the left hand side. Let me just show you what I'm talking about. Okay, this is okay. You can see we got a new folder called vector store db Faiss, and you can see index.Faiss and index.pkl, and you can see it is stopped. It means our ingest.py file has been successfully ran, and we have now all of our vectors stored in a vector store. So we are good with our embeddings, guys. Now in model.py, let's write these functions quickly. So I'm going to write a custom prompt here. So let me write a custom prompt template. So I'm going to write custom prompt template, and in this custom prompt template, let's write something good here. So in custom prompt template, what I'm going to write is use the following pieces of information to answer the user's question. If you don't know the answer, please just say that that you don't know the answer. Don't try to make up an answer or something like that. Make up an answer. Make up an answer. I have a little sore throat, guys, and cough and cold. Sorry for that. And then I'm going to also need a context, and my context is nothing but this context will come from the LLM and this the knowledge base. And then we have question. This is the question from the end user, and let's write only returns something like this. Only returns the answer, only returns the correct or factual or helpful answer, something like that. Helpful answer below and nothing else. This is okay. And then here we'll have our helpful answer. That's it. That's what we are done with our custom prompt template, and that's we are gonna use a LangChain here, guys. That's why LangChain is so important to use. Okay, so let's do that. So what I'm gonna do here is I'm gonna write a couple of more functions quickly. The first thing is let's set this custom prompt. So define set custom prompt, and I'm gonna call it custom prompt, and this will have no parameters. Let me just write. So let me define this into this. So I'm going to write some documentation. So prompt template for QA, prompt template for QA retrieval. QA retrieval for each vector stores. So the context that you see, right? That's the power of our knowledge base that the embeddings that we have created. Okay, now in below this, we're going to write our prompt. And our prompt is nothing but we are going to use a prompt template function from LangChain, and we're going to pass template, and this template is nothing but our custom prompt template that we have defined, and we're going to pass input variables. So let's pass this input variables, and this input variables are nothing but the first one is context and the second one is the question inside a list. So you can see we have a list inside question. That's it. And then we're going to return this. Return prompt. We are okay with this, guys. Now, so we are okay with this function. Now let's write other functions. The next function that we're going to write is retrieval QA chain. Or should we write load LLM? So let's write a function for loading this LLM model, the model that we have, right? So let's write that, and that's where we'll use C transformers. So I'm going to use LLM, and I'm going to use C transformers inside this. All the magic will happen inside this. I don't know why I ran this. I'm just going to do a Control G here and exit. You can see C transformers, and my model is nothing. So my model, I have to take this. Let me just go back here in this model properties, and I'm going to just copy this, guys, the path and everything, the name there, and I'm going to paste this over here. That's it. This is my model and my model type. Now C transformer also, look for your model type, because it also supports different other model types. So it has Llama, it has different model types that you can use, Vicuna, etc. So model, and then I'm going to pass type here. So my model type is nothing but it's Llama. So Llama, and then I have max new tokens, couple of hyperparameters. So max new tokens, and let's keep it 512 for now. Max new tokens. Then I have temperature, and let's keep it 0.5 as a temperature. That's it. We are loading our model, guys, and now we're going to return the LLM here. So return LLM, large language model. So we are okay with our function. Now we are loading the model. So you can see the changes that we have done. We are not using a transformers from pre-trained or auto causal LM, but we are relying on a C transformer, the Python bindings, for transformers in C and C++, because it's really fast. You can also explore VLLM. You have to check that as well, guys, from GitHub. Please have a look on that as well. So retrieval, and I'm going to write one more function, retrieval QA chain. And in this, I'm going to accept LLM prompt DB. I think I have to write the code for DB as well, the function there. Okay, we'll see that. Now, retrieval QA chain, LLM prompt and DB. Okay, I'm going to define a QA chain here. And in this QA chain, I'm going to pass retrieval QA dot from chain type. We're going to use a chain type. from chain type, and here we go. So retrieval dot QA from chain type LLM equals LLM, and then we have chain type. We're gonna use a stuff chain type. You can also look at map reduce etc as well, or summarize and something like that. Okay, so stuff in this case I'm gonna use stuff, and then we have retriever. So let me do that. So retriever, I hope I spelled it right, RIE, yeah, I think so, DB as retriever, and it's gonna take search quarks. So search quarks, and it should take number of searches that you want to do. So I'll have 2 here. Okay, this makes sense. And I also need return source document. We have to explain the output, guys, to the end user, because we assume, or not assume, I think we should retrieve the response from the knowledge that we have fed to the system, because Llama 2 will also have its base knowledge. Okay, we don't want to do that. We want to only return the knowledge or the information from the document that we have fed to the system, and that's why we're going to do return source document here in this case. So let's do that, guys. So return source document, I don't know why it's capital there, return source documents. It's true false boolean here, so true. Okay, return source documents, and then I'm going to also use chain type quarks, because I have to pass that prompt here, right, the custom prompt that we have. So chain type quarks, and in this it's going to have a prompt. So let's do that. So prompt, and it's a key value pair, so I'm going to pass a prompt here. It's a dictionary, so you can see the prompt that we have passed. That's it. So we are going to return this QA chain now. So let's return this QA chain. That's it. We are done with couple of functions, guys. So what we are doing in so far, we have imported the libraries which are required. We have given the path of our embeddings. We have a custom prompt template. The better you write prompt, better responses you will get. So you can explore this. And then we are setting a custom prompt, a function that return the prompts using LangChain prompt templates. Then we are loading the LLM, large language model, C transformers, and then we are loading this model by the block, the quantized model, GZML model, and then we have a retrieval QA chain that basically combines all of these. Let me open my cast here so I can also explain a few things. So now what we're gonna do here, we have to write a couple of more functions. So let's do that. So define QA bot. And here we'll use our embeddings. So embeddings, and probably we should write this function on top, and I'll do that, guys. So Hugging Face embeddings, and this remains same. I don't know why I'm writing this. So let me just do one thing. Let me just remove this thingy from here and take the code from ingest.py. This remains same. So I'm just gonna use copy paste here for this, and I'll come here and I'll just paste this. We are okay with embedding. So now let's do one thing. Embeddings are done. So let's db, and again Faiss. So Faiss.load local. Now in the ingest.py we did save local. Now we have to load local. So in load local, what I'm gonna do is I'm gonna give this path of db Faiss path and the embeddings on the fly, and then I'm gonna use this LLM. So for that I'm gonna use load LLM. You can see this load LLM. And then I also need a prompt, so I'm just going to call it QA prompt, and this QA prompt, so let's use the set custom prompt function that we have used. Set custom prompt, and the last one is QA variable that will combine the QA chain. So retrieval QA chain function, and I'm going to give LLM and QA prompt and DB. That's it. So we are utilizing all the function that we have written on top in this function. I'm just going to returning QA. Excuse me, sorry. I'm just going to return this QA, guys, here. That's it. So we are okay with our function now. So we have completed the functions for the model load and also the retrieval QA chain. The last function for this part at least, and then we'll write the chainlit, couple of functions for chainlit. Now the last function is, we need a final result, guys. So let me just do that. So final result, little bit of output parsing, not much, and the query by the end user. If you are building a Streamlit app, that will be easier for you to just take this function and run it through a Streamlit text area or text input. But we are going to rely on Chainlit in this. So QA result, and I'm going to call this function on top, and I'm going to pass my response variable into this QA result, and this will have my query, which is a key value pair dictionary here. That's it. Here you go. So if you run this now, it should return the response on your query. So you can do a print or something like that in terminal, but you can play around it. I'm going to write the code for excuse me, I'm going to write the function for now chainlit. So let me just do that. So I'm going to write chainlit code here, and I'm going to use some chainlit. So if you see here is we have chainlit overview. You can see the chainlit documentation. It's very powerful, guys, an open source Python package that makes it incredibly fast to build and share LLM apps. Okay, it provides you a conversational interface. So we need some decorators. It has some inbuilt decorators. You would have seen it in microservices if you're working with Flask, Fast API or Django. And that's what we're gonna do. So the first thing is cl dot on chat start. So what we're gonna do, the first thing is when you start the chat, okay, this should get loaded. Okay, so on chat start, I'm gonna write an async function which check. So async, and let's write this function called start, and inside this we'll write our code guide. So the first thing, I'm gonna use this chain equal to QA bot. I'm gonna call this QA bot function here, and I will have a message variable, and inside this message variable I'm say okay, I'm gonna use cl.message chainlit.message function, and I'm gonna write my content here. So let's write this content, and this is nothing but starting, the bot. Okay, this is my message to the end user when we logged in immediately, on the chat start. So the message, and I'm gonna use an await here message.send. Okay, so you send this message once this gets loaded, and my message content, there should be a message content, and then hi, welcome to. Once it gets loaded, this would get printed there on the Chainlit UI. Welcome to the medical bot or something like that. Okay, medical bot, what is your query? Something like this. Okay, what is your query? And then we update the message now, because in the previous call we said message.send. Here we'll update this message. So message.update, and let's do that, and let's clear this. So cl.user session, or not clear, user session.set. Let's set this user session.set, cl.user session.set, and this chain, and then we pass this chain variable. So this chain variable gets our QA bot. That's the first function that we have in Chainlit. Now you can explore Chainlit documentation if you want to put some images or in some markdown or something. They have this as well. Okay, it's extremely powerful, guys. Chainlit, it's good to build LLM based bot, because it provides you the interface, and it also gives you a tracking mechanism. You can really track which functions are being called, okay, without writing a lot of code explicitly. It provides you, it's inbuilt there. So let's write the last function that will get all this result and responses on the Chainlit. So what I'm doing okay, @chainlit, the decorator, on message. So if we get the message, so on message, and here I'm gonna write that, guys. So async def main, this is our main, and it will have a message parameter. So let's, excuse me, message, and here I'm gonna write our chain. So cl dot, this is what I need. So I just copy this, I can see it. So I just need this, and I don't need this chain anymore. Okay, this chain will be called, okay, so cl.user session, and then I have a callback. So I need a callback here, guys, a callback function. So I need cl.async lang. So we are using langchain, so it has something called async langchain callback handler or something like that. So let's use that callback handler, and inside this I'm gonna pass a streaming message response. So you can see a stream final answer excuse me, stream final answer, and that it's going to be true, and then answer prefix tokens, and answer prefix tokens, this should be final answer. So let's write like this, final answer. And I think we are done with this. So now we have a callback handler which says stream final answer true, answer prefix tokens, final, and answer. Now what I'm going to do is if answer is reached, so CB answer reached true, call back that answer reached is true, then print it, so result, and then await chain dot await chain dot, let's have an asynchronous call, so a call, and then message and call back. So it's not callable, it's callbacks. So callbacks should be inside a list, I probably assume that, so CB. So callbacks equals CB. Now we have our answer here. So answer is nothing but our result, answer response result, and then sources, and sources are nothing but result and it's source underscore document. So I already have done this, guy, that's why I know that how I can parse the output. You can also explore that, you have source document, you have result, right? So I'm just parsing it. Okay, just you can do a split as well. If you're not using Chainlit, you can just do a split or something to get that value out of it, of the final result. And I'll just have a condition here. So if sources answer, and then it, okay, we have to augment, so let's have answer and then f of, let's have a line break, okay, and sources, and this should be your sources, but I think we have to wrap this in a string, probably string, yes, I think so. So let's do string. So we are okay with this, and now have an else here. So if, just say no sources found, okay, no sources found, something like that. Okay, if there is no source for that answer, and that's it. Just a last line here, guys, just to give a message that our content is answer, and just do a send here, that's it. So now we are sending this on the UI, and it's a function. So now you can see what we have done. So we have two functions, two decorators for Chainlit. The first is to start the app, we are using this QA bot, okay, and now we are sending that message.send, starting the bot, and once it's done, we update that screen, okay. We said, hi, welcome to the medical bot, what is your query? And now in the next one, on the message, when the user gives that input, asks a question, is basically uses that function, the chain here that you can see, the chain that it uses QA bot chain, right? The QA bot will get triggered and it will get the answer and sources, and we're just using, if there are source, execute this one, and if there is no source, execute this one, and just send the message. So chainlit.message send. So we are just printing this answer, guys, here. So let's now run this, and we'll probably see our medical chatbot that we have created using Llama 2, and that will run on a CPU machine, guys. So let's run this. So now in terminal, what we're gonna write is chainlit run model.py file name, and then -w. So let's run this now, chainlit run model.py, and let's see. And now you can see that first you saw a readme. You can also see this readme here. It says, hi there, we are excited to have you on board. This is a powerful bot designed to help you ask queries related to your data and knowledge. You have some useful links, data, join AI anytime community. You can also join our community on WhatsApp group, and you can share, where we share your projects and a job opportunity, internship, blah blah blah, right? The happy chatting. Couple of other, you have this chat here, guys. You can see, hi, welcome to medical bot, what is your query? Now this is a conversational interface, and that's why we are using Chainlit. Earlier we have used Streamlit in most of my videos. I also have some interfaces that are built with Bootstrap, with powered by Jinja 2 in Fast API. I also have done that, but we are trying it for the first time, Chainlit here, which looks good, apart from Gradio and Streamlit that we have seen in Python, right? So it's also a Python package. You can see built with Chainlit, and you have this bot, and you have these settings also. You can make it dark mode also. You can see the dark mode. Okay, if you are fan of dark mode, you can do dark. Okay, but I'm just going to keep light mode for this right now, and I'm going to ask a question. And you can see I asked a question, and you will probably see this, the response was very fast. Do you know the reason is because it's already in the memory, because when I was recording this video, when I started this in beginning, I was showing you, I asked the same question, and you can also see that the question that I have asked here, all the previous question, it gets in the memory here, last messages, and that's why it's very fast. And it's not going to the model again and getting the response, which is a very good thing, by the way. Okay, and that's what I like Chainlit, and it also has a answer, and it also has a source. Let's ask a question. So let me open this document, and I'm going to ask a question from this document, guys. Let's ask that we haven't asked yet. Okay, maybe what we can ask. I'm looking for a simple, I'm not that good in, finding out the question from document, but I don't know what question to ask. Let me ask a question. Let me see a good enough question. So, should we ask? It's such a huge file. Okay. Amino acid disorder screening. Let's ask this question. What is amino acids disorders? What was that? Disorders screening. Okay, I'm asking this question. I have a temperature of 0.5, so it will be really creative, I think. Disorder screening. Now, this is my query that I'm asking. It's on a Chainlit, conversational interface, and we are going to leverage Llama 2. The Llama 2 will respond from the embeddings model the model that we have used for embeddings, the base, the model, that the knowledge base that we have created, right? What is amino acids disorder screening? Let's hit enter and see. Now, once I hit the enter, you can see it says using retrieval QA, and that's a very good thing, by the way, because it's explaining you can keep a track of your the function. You are getting your, now you have different functions. You can track which function calls, okay, which have been called, right? Now you can see it says now it's running right now stuff document chain. Now you go inside that, you can see using LLM chain. Now if you go inside, you can see it's running. So the LLM chain is being running right now, okay, in the backend. So you can keep a track of all the function calls, okay, retrieval QA or what kind of document chain you are using. And the same thing, you can also remove it, hide it from settings. Okay, we'll see that. So from settings, if you hide the chain of thought, probably you will hide this. Okay, now, so it will take a little time because it's running on a CPU machine. So I think for one response, it's probably take around a minute. So it takes 1 minute up to 2 minutes or sometimes also. And your internet speed has to be fast. You can see it says could not reach the server because it's connected with on localhost 8000 with your machine, which requires right now could not reach the server. So that should be there. Okay. So let's wait for it. Will take a little time, and meanwhile I'll show you the model which I've taken the model from here on Llama, the block model. Let me just close it. We are using Chainlit. The link will be given in the description for this as well, guys. And then we have C transformer that we have used. So C transformers here. You can see it's running, is still here. So let me come back on. You can see it's batches 100%, right? Successfully loaded fast with AVX to support. Loading fast with AVX to support. You can keep a track of it, everything over here. Okay, now if you, so terminal, let me minimize this. Here is the code. Now let me go back, and you can see now, okay, you can see that we have got our response here, which says amino acid disorder. Fantastic, right? Amino acid disorder screening is done in universe, and we also got our sources, right? We can ask more questions as well. You can ask follow-up questions as well, and you can also use conversational retrieval memory, guys. And this is why I wanted to run this on CPU machine. Okay, fantastic answer that we got. Let's ask some other questions as well. So I'm gonna ask the other question as well, guys. So let's ask this one more question here. Now, which question we can ask? Okay, Bartholin's gland cyst. Okay, something like that. Okay, let me see a tricky question. I'm looking for a tricky question. let's ask, how can we treat Bartholin's gland? Okay, so let me ask this question: how can we treat Bartholin's, what is that? Bartholin's gland. What was that? Bartholin's, right? Bartholin's gland. If it is infected. Now I'm asking this question: how can we treat Bartholin's gland if it is infected? Now when I ask this question, you can again track it using retrieval QA, and if you expand this, you can see it says using stuffed documents chain, using LLM chain, and running. So this fantastic, right? It's a, and you can also stop task. So the same way you have in Chat GPT, stop generating or something like that, right? The stop responses. So it's provide you a very good, conversational interface. You also have README here. You can also design it a bit. You can change this. You can put your own here, name or something like that, in taskbar or something. Right? You can do that. You have to go through the documentation. You can also clean these sources. The way we are returning the sources, there are option of make it clean. Okay, you can also show the PDF inside it, the data that you have. Now here you can also click on settings and dark mode. You can see in the dark mode. Now how are we seeing it? It also takes your system time. You can see 2029. Currently we are on 2037. You can see it's running 2036. So it's very powerful, guys. Okay, when it comes to building a conversational interface using Chainlit. So let it load. This is the last question that we are asking. Okay, and so this will, the entire code will be given in the description. You can find out through GitHub. So that code will be available on GitHub. You can go ahead and take the code base from there, and let me know what are you building with this model, the quantized model with C transformers and GGML2. They are rescuing basically for people who have limited compute power. You can use this model locally on your CPU machine for your task, right? And that's the beauty of it. So let me know what you are doing with this kind of model, guys. Let it load, and we'll see. You can see it will say batches 100. You can see the output we got our output. So you can see that if a Bartholin's gland becomes infected, it should be evaluated and treated by a healthcare professional. Wow, familiar with the treatment of this type of infection. And then you can see the document, and this is important. It's giving the response from our guys, our knowledge that we have fed to the system, and it's a QA bot that we have built. But you can try it out something else as well. But this is what I wanted to show you guys in this video. You can see a simple and powerful bot that we have built using Llama 2, and we have loaded that through C transformers that supports GGML models. And thank you to the bloke again, and I hope you like the video. If you like the video, please hit the like icon, and please share the video with your friends and your circle. And if you haven't subscribed the channel yet, do subscribe the channel, guys. I have been working on many other videos that I have recorded. I'll post it. Those are very interesting now, because we are also going to release video which will not only help you create this kind of demo, but also how you can control hallucinations, how to look at guardrails, governance, data protection, and privacy when it comes to large language model powered application or solution. There'll be a few videos on those lines as well, guys. So looking for your support and guidance as well. Let me know any thoughts, if you have any thoughts and feedback for me in the comment box. I'm not feeling well. I was not well, but I wanted to record this video. I am suffering from influenza, but that didn't stop me to record this video, guys. I hope you liked the video. So thank you so much for watching, and that's all for today's video, guys. See you in the next one.